So far, we have covered few things under the fit functions, including the usage of history objects and the usage of callbacks. In this video, I will go through the last important topic under the fit functions, that is the usage of batch size. Fit functions trains a model by slicing the data into batches, that is the batch size, and repeatedly iterating over the entire database for a given number of epochs. There are three different types of gradient descents that I mentioned at the very beginnings, and that match with different numbers of batch size. Firstly, we have stochastic gradient descent. If that is applied, then the batch size is equals to 1. That means a single sample is randomly picked and used to compute the gradients of the cost functions for each epoch, and then that will update the parameters. And then for batch gradient descent or vanilla gradient descent, if that is applied, that means the batch size will equal to the total number of samples. That means the entire dataset will be used to compute the gradients of the cost functions for each epoch of the gradient descent and then updates the parameters. Finally, we have a balance between the stochastic gradient descent and batch gradient descent, and that is the mini-batch gradient descent. If that is applied, then the batch size is larger than 1, but less than the entire number of samples, less than the total number of samples. A mini-batch of samples is randomly picked and used to compute the gradients of the cost functions for each iterations of the gradient descent and then update the parameters. There are reasons that we do not go for stochastic gradient descent and also batch gradient descent. If the batch size is too small, the model weights can be easily affected by small portions of the data. It means that the optimization will be very fluctuated, and it results in a less accuracy estimate of the gradient. However, if the batch size is too large, that means the entire number of samples, it can cause out of the memory issues, especially with very large data sets. It means the training will be extremely slow. For these reasons, mini-batch gradient descent is preferred methods. So smaller batch size are often used instead of 1 or instead of the total number of samples. By default, Keras applies mini-batch gradient descent and with 32 samples. And the advantage of using mini-batch gradients is that because the batch size are relatively small, that means they can offer a regularization effect with lower generalizations error compared to the stochastic gradient descent. For smaller batch size, it also makes it easier to fit one batch worth of training data in memories. In that case, it's much more easier for us to avoid the out-of-memory issues, especially when we are using a GPU. Therefore, the default value, 32 samples, is a very good starting point. And that's it for the fit functions. In the next video, we will talk about the evaluation functions and why and how evaluation functions use training, validations, and testing datasets to help us in evaluating the models. See you in the next video. Bye-bye.